You can just see like Encore. This is implementing and operating Cisco Enterprise Network Core. So this is one of the exam that has Cisco SDA as a part of its content. And then we have like Enterprise Infrastructure Lab exam. Here also like we have some in the Cisco Enterprise Infrastructure Lab exam. Here also we have some content regarding the SDA. So there is no official certification for the SD-Access. So not at least from the user point of view. Like there are some partner certifications that we don't need to worry about. So those are specifically for Cisco partners, like internal training and all that thing. From the end, like from the user point of view, from like normal individual person point of view, there is no official certification for Cisco SD-Access. They might launch it later on, but at the moment there is nothing. So the SDA content we are going to cover from the Encore and the CCIE Enterprise Infrastructure Lab exam. So if you take a look at the Encore Enterprise Core technology, so if you click on this view exam topics, here this Cisco SD-Access, if you go to the architecture tab, here in the architecture tab, we have this right here, we have the content regarding the SD. Explain the working principles of the Cisco SD-Access solution, SDA control plane, data plane elements, traditional campus interoperating with Cisco SDA. So this is the part that they have regarding the Cisco SD-Access in the Encore exam. Rest is like switching, wireless, SD-WAN, then again wireless, then some tables and all. But here is the thing that we have to focus on. Here is the part that we have to focus on. This is the SDA content. Then if you scroll down in virtualization, we have this Lisp and VXLAN. We are going to cover this in the SDA as well. Whatever things are necessary for us to know regarding the Lisp and VXLAN from the SDA content point of view, that we will cover. It is not going to be a complete Lisp classes. It is not going to be a VXLAN classes. It is going to be a class focused on Lisp and VXLAN as per our content. So in our content, the use of Lisp and VXLAN is only with regards to Cisco SD-Access. They do not want you to configure the VXLAN manually. They do not want to configure the Lisp manually. They want you to know what exactly is Lisp, what is VXLAN, why we use Lisp, why we use VXLAN, what is the use of this Lisp and VXLAN in our Cisco SDA solution. So that definitely we will cover. We'll talk about Lisp, we'll talk about VXLAN in as detail as possible as per our content, focusing on our content. It's not going to be a complete Lisp classes, by the way. It is not going to cover the entire VXLAN. Those things are like, for example, if you want to know VXLAN, you can definitely look up the data center service providers, like, those classes. Especially in the data centers, you will study about the VXLAN. But yeah, we will cover the Lisp and VXLAN. You will at least know what is Lisp, what is VXLAN, the terminologies used in the Lisp, the terminologies used in the VXLAN. In fact, I will also show you the configuration of the Lisp and VXLAN, but I will not do those configurations. Those configurations will be pushed automatically with the help of our SDA controller that we will talk about. So I will show you the configuration. I will explain you each and every command that is there in the configuration, but we are not going to configure it manually. Neither Lisp, not VXLAN, but we will cover it. So this part of the Encore will be covered as a part of Cisco SDA classes. Then the infrastructure, in the infrastructure, we do not have anything regarding the SDA here. So in the infrastructure tab, in the infrastructure module, we do not have anything regarding the Cisco SDA in here. So no need to worry. Network assurance, we are going to use, we will see the use of the DNA Center workflows. How can we use Cisco DNA Center or Catalyst Center? How can we use this DNA Center to apply network configuration, monitoring, management? How can we do all those things from a centralized point? That we will talk about in the network assurance section. So that part we will cover as a part of Cisco SDA. Then under the security, AAA we will configure in the SDA as well. We'll talk about AAA. We will talk about .1x, although it's wireless, but we will talk about like AAA. We will talk about like .1x, how the port-based authentication basically works in our Cisco SD-Access. So we will talk about this. We will talk about the .1x based authentication. We will talk about like the security in the Cisco SDA network as well. We'll talk a little bit about ICE, Identity Services Engine. How to, what are the components of the ICE, why we use Identity Services Engine, what are the benefits of the identity services engine, how ICE integrates with the SDA controller, what things we can do from the SDA controller, what things we can do from the ICE. All those things will be covered as a part of our content in the SDA. That part we will definitely talk. So AAA functions we will talk about as a part of our SDA content. And then under the automation, we will talk about here we do not have anything that we need to worry, but we will talk about the DNA Center API. We'll talk about like what application programming interfaces, what APIs are available in our DNA Center, Catalyst Center, SDA controller, what APIs, what options we have in our Cisco SDA controller to manage that, to control that SDA controller from outside the network. So let's say we have some automation programming tool and we want to create some scripts, and based on the scripts we want to change variety of things or retrieve variety of things from our network. How can we do that? That we will talk about that as the at this point, like APIs for the DNS Center. We'll talk about like how DNS Center interacts with the application programming with the help of the application programming. So this is from the NCore. This is from the NCore that we are going to cover. You have to be, I'm going to be very specific with the content. So this is the content from the NCore that we are going to cover regarding the Cisco SDA. So whatever things you see regarding the SDA in the NCore content will be done. It will be covered. It will be completed in our classes. So that we will talk. Not a lot of things are here when it comes to like NCore content. Not a lot of things are here regarding the SDA. But when we go for CCIE Enterprise Infrastructure Lab exam topics, there we have the SDA content in very much detail. There we get to know like exactly what things we have to focus on in our SDA. So in the NCore, which is more like the written exam, so here we have very basic things. But when it comes to Enterprise Infrastructure Lab exam, there they have a dedicated section, software-defined infrastructure, and here they have a dedicated section of the Cisco SDA. This is a dedicated section of the Cisco SDA that you should know from the technology point of view. This is what you should know from the technology point of view. This is part of our content that we will talk about. Cisco SDA, what is underlay? What is underlying infrastructure? How to build the underlay manually? How to build the underlay automatically? What is this PNP? How to discover the devices? How to manage the devices from a centralized point? What are these extended nodes? Policy extended node. What are these devices basically? So the components of the underlay. What is underlay and the components of the underlay? And how do we build the underlay network? That we will talk about as a part of our SDA. Then overlay. Overlay basically means once our underlying infrastructure is ready, then we are going to build a logical network on the top of that underlying infrastructure, which is what we refer to as the overlay network. Overlay network is basically built with the help of the tunnels, just like the DMVPN, just like the GRE. So overlay, what is overlay? What is SDA overlay? What are the components used in the SDA overlay? What is this Lisp? What is this VXLAN? What is this Cisco TrustSec or CTS? What is this layer 2 flooding, native multicast? These are the concepts of the overlay that we will focus on as a part of SDA. Regarding the underlay, regarding the overlay. So we'll talk about the underlying infrastructure, then we will talk about how the SDA is going to build a logical network on the top of the underlay infrastructure with the help of protocols such as Lisp, with the help of the protocols such as VXLAN and Cisco TrustSec. So control plane, data plane, and policy plane. These are the three components of the SDA overlay network. One by one, we will talk about each of them. We'll talk about the Lisp BGP, we'll talk about the VXLAN, then we will talk about the Cisco TrustSec policy. Then what is a fabric and how to design the fabric, that we will talk about. Like how can we design the fabric? So we have one site. In one site we have a few devices. We have, for example, a few switches. How are we going to design our SDA fabric with the help of these? In a single site, how are we going to design our SDA fabric? First of all, what is a fabric? And how are we going to design the SDA fabric in a particular site? So here is our site number 1. In the site number 1, we are going to design our SDA fabric. So fabric concepts and how can we design the SDA. Then what if you have multiple sites? You have fabric site 2. How are we going to connect these fabric sites with the help of transits? Transits basically means a way to connect multiple fabric sites together. So how are we going to connect these fabric sites together? How are we going to connect our SDA fabric to the non-SDA network? like a network that is not even running the SDA. How are we going to connect the SDA fabric? How are we going to connect our SDA network with the non-SDA network? So what is a fabric? What is a single site fabric? What is a multi-site fabric? What is fabric in a box? What is like on the same device? What is a fabric in a box? Fabric in a box basically means that we have one particular switch platform, and on this switch platform we have created the fabric. Like we don't even have like multiple devices in our network. Like we have just one catalyst switch in the network, and we have created our SD fabric in that particular switch itself. So that, like, what is the fabric in a, what is fabric in a site feature that we are going to talk about. Then handoff basically means like transits and fabric border handoff. Like how are we going to connect two SDA sites together? How are we going to connect the SDA site to the outside network? Like SDA, what is the SDA transit, SD-WAN transit, IP transit? What are these different types of transits? Transits are the way by which we can connect our SDA fabric with the other SDA fabric or the non-SDA fabric. So what are different options that we have for the SDA transit? What is this fusion router? What is this peer device? What is this fusion router? What is the role of the fusion router? How to configure the fusion router? What is the role of this fusion router in the transit? We will talk about. What is this layer 2 border handoff, layer 3 border handoff? Basically, handoff means like handing of the prefixes, handing of the SDA prefixes to non-SDA and non-SDA prefixes to the SDA domain. So what is this layer 3 handoff? What is this layer 2 handoff? We will talk about as a part of our. Then we will talk about like how to onboard the host. Then we will talk about like how to onboard the host. Host onboarding. Host onboarding means like connecting the end user. How are we going to connect the end user in the SDA fabric? How are we going to connect the end user in the SDA? So host onboarding, authentication template, port configuration. What is this multi-site remote border priority, adding the device to the fabric, like how the end user onboarding happens, that we will talk about. And finally, the micro segmentation and macro segmentation. Micro segmentation basically means like we have, let's say, macro segmentation is just another way of saying like a VRF based segmentation, and micro segmentation basically means like within, let's say, for example, a VRF, we want to perform the segmentation at much more smaller level. Then we have this thing called a micro segmentation. So macro segmentation and micro segmentation. Macro segmentation and the micro segmentation. So this is policy. This is regarding the, this is mostly the policy part. So micro segmentation and the macro segmentation we will talk about at the very end of our SDA classes. So these are the things that we will cover as a part of our SDA content. Like this is specific to CCIE Enterprise Infrastructure. This is like CCIE Enterprise Infrastructure. This is CCIE Enterprise Infrastructure lab exam topic. This is from the lab exam. This is the content that we will focus on. Apart from that, we'll talk about the other things as well, such as we will talk about like AAA, ICE. We will talk about a little bit about the wireless, AP, WLC, and all those things. Those things will be covered additionally, but our main focus is going to be on this content from the SDA in core and this like CCIE Enterprise Infrastructure lab exam content. And also at the very end, we do have the automation programming. So this part right here, interaction with the DNA Center using the API, that part will also be covered. That part, like, we will also talk about like how to cover that part. We will also talk about that.
So I have like one question. I think you have covered everything, and that we are like thinking. So the another questions like, are we like covering the theory only, or are we doing the practical?
No. Yeah, it will be like a lab session as well. Let me show you that in fact as well. So we do have a few, like we do have like a DNA center along with some physical equipments here in the premises, and we are going to do everything that we have discussed. Like not everything, basically whatever thing is in our content, we will talk about all these things from a lab point of view, from the configuration point of view as well. Such as, for example, here is one DNA center that we have in our premises, and one class is already going on, by the way. So here, for example, we have a network of 4 devices at the moment. We have 13 sites, and also we'll do these things in a practical way as well. Like we'll do all these things in practical, creating the fabric. covering the devices and all.
So in case we have to create the lab, is it possible if we can create
No,
on EVNG?
no, it's not possible. That is where I'm coming to the next point. Like our next point is like how the lab and everything is going to be done. So let's talk about that actually. So, but the point is that whatever thing is in our content from the lab point of view, from the technology point of view, I will cover it like in the practical sessions here. Like for example, this is like these are 4 physical switches that we have in our premises, and such as this is switch number 2. This is a 9300 series switch. This is a Catalyst 9300 series physical switch that we have in our premises, and we are controlling it with the help of the DNA Center. We are creating the fabric and all those things. So all the discovery part and everything, basically everything we have set up from the scratch. So I will do the same for your classes as well. So I will do everything from the complete scratch, and I will show you everything like how to build the fabric, how to discover the devices and everything from the complete scratch. So it will be a mix of technology as well as the practical training. So both will be mixed.
Okay. And I think in this SDA training, we will cover a little bit of like DNAC. So in case we have like,
Little bit of like DNAC, you're saying little bit of DNAC, right?
right. Is it?
This will be covered like mostly like everything. So not so design tab will be completed, policy tab we will cover, provision tab we will cover, assurance tab we will cover, tools we will cover, activities, reports are nothing, systems we will cover. So I would not say little bit. Most of the things we will cover from the DNA Center. A few things like, for example, these things, for example, how to integrate those external services such as umbrella and all those things, those I will not. But most of the things we will cover. Like I would say like 60-70% thing from this Catalyst Center, or even more, we will cover.
Okay. DNA plus SDA.
DNA SDA is basically a solution within which like the DNA Center controller is used. So SDA is just this one. SDA is just one part of the DNA. So like apart from this SDA, we will also talk about like the wireless. We'll also talk about the policies. We'll also talk about the design. We will cover like we'll not focus only on this one. We will cover everything from the scratch. So even in this lab that you are seeing right here, everything I have configured from the complete scratch. So see all the sites and everything. So I will cover like most of the things from here.
Okay.
So I have a question, sir. Are we covering ICE integration like with the
Yes,
DNAC?
yes.
Okay.
Yes, we will do the ICE integration, but I will not cover ICE from this like complete scratch all the way to the expert level. I will not do it. I will explain what is ICE. I will explain the role of ICE in our production environment. We will talk about the deployment of the ICE. We will talk about the different personas that we have in the ICE, such as PSN or PX grid and all those things. And then we will talk about like what version of the ICE is compatible with the DNS Center, and we will directly basically integrate the ICE, and then we will create the policies right from here, and then we are going to create the policies on the ICE. So it's not going to be an ICE training, but the integration and everything we will definitely do.
Okay. So sorry to ask you this question. Like the entire course will take like a month or 2 months?
Yeah, we'll talk about it. I will show you an index to get a better idea, like how long it is going to take for the completion of the course. We'll talk about it.
Okay, so the context, as you already mentioned, this one, the context is it will be covered for like it's a CCIE context. Yes.
Yes, this is specifically from the CCIE content point of view, like the ENCORE exam. Since there is no official certification for the SD-Access, not at least as of now, so we will focus more on the ENCORE topic and the CCIE Enterprise Infrastructure Lab exam topic, which has like pretty good like SDA content, like it is in very much detail. So we will focus on that, and that will be like from the production environment point of view also, like it will help you a lot, because like most of the things that we do in the SDA in the production environment, it is there in the content of the enterprise infrastructure and the ENCORE. So pretty much like overlapping you will see. So it will be helpful from the production environment as well. In the production environment, you will use it like more than what they have mentioned in the content, but you will get the idea of the controller, you will get the deployment options, you will know a lot of things regarding the SDA from the production point of view as well. So not only from the lab exam point of view, but also from the production point of view, you will get like sufficient amount of.
Okay, so this could be the last question, sir. Whoever is like pursuing for CCIE, lab exam in future, so do they need to come back to these classes, as a solution base, or this is the class we need to go through it?
This is it. Like if you have gone through these classes like properly, like if you have watched the recorded sessions, maybe probably like made some documents or so. You have just at least repeated all those things on a virtualized environment, and it will be sufficient. Like you will not like require to take any additional training or anything. So it will be sufficient. This content will be enough. More than enough, I will say. Unless of course something changes, unless something they add in the content later on. But from the current lab exam point of view, it is more than enough. It is more than enough.
Thank you.
So there are a few books definitely that we can refer to. There is no official certification. There's no official certification for the Cisco SDA, but there is an official book from Cisco that we can refer to for good amount of knowledge. So it's still relevant, even though the SDA version has updated like a lot, but still like the content inside that book is pretty much relevant. So we are going to use you are going to use a few books for your technical understanding, such as, for example, this is one of the book. This is the official book from the Cisco that we have to refer to. This is one of the official book from the Cisco. This is one of the official book from the Cisco that we have to refer to. So, it is a very old book. In fact, this book came before the SD-WAN book. So Cisco Software-Defined Access, Cisco Secure Enterprise. So this book has a few chapters here, right here. We have total 9 chapters in here. We have a total of 9 chapters here. And in these 9 chapters, you will be able to complete everything. Of course, as per the content point of view, you will be able to complete all those things from the content point of view. And of course, from the production point of view, a lot of things will be covered. So the first chapter focuses on what exactly is like the first chapter focuses on what is like how we are going to use the modern day network. What are the challenges in the modern day network, which we will talk about as well. So what are the challenges in the modern day network and all. So that we will talk about. Today's network and the drivers for the change. What is the Cisco SDA? What is the DNA Center? What is Cisco SDA? How it is going to help in overcoming all those challenges? And then what is the role of Cisco DNA Center? What is the requirement? What is the role of the DNA Center in the Cisco SDA solution? How DNA Center is going to help us in the Cisco SDA solution? That is there basically. Then SDA fundamentals. Then the SDA fundamentals. Then the SDA fundamentals. Cisco Software-Defined Access fundamentals. Then ICE. Then SDA operation and troubleshooting. Advanced SDA topics, advanced DNA Center topic. Advanced SDA topic and advanced DNA Center. These are the things that are covered in this book actually. These are the things that are covered in this book.
So I have like one question. I think from they have changed the name of DNA Center to Catalyst Center.
Yes.
So is this like drastic change, or did they just change the name only?
No, just the naming convention has changed.
Just the name.
So that's why like these things will still stay like pretty much relevant. So just the DNA Center that we have, the name of the DNA Center is changed to the Catalyst Center, but the terminologies, the border node, control plane node, and all those terminologies still remain exactly the same. So it's still pretty much relevant, right? So these are in very detail, by the way. In fact, like in first few chapters, they have only explained that why did we create the DNA Center, what was the requirement, and also just a few chapters like describing like what is the need of the SDA, and then like what this DNA Center controller will do, and also it's pretty much in detail. It's very much in detail, like you can go through these 9 chapters to cover in and out of the SDA and the DNA Center operations. The other book that we can refer to, or you can refer, there are plenty. Documentation is very good. No need to worry on the documentation part. Documentation is very good. We will also refer to some official documentation from Cisco website itself later on in our classes. Documentation is very good. This is a second book, for example, like this is software-defined intent-based, enabling intent-based networking. This is a second edition. This is a very cut to cut, very precise book, basically focusing on the important concepts of the SDA. So very small, like, very small book, but very precise. So like what is like SDA overview, then like SDA fabric, then like DNA center policies and everything directly. That's it. So like, automation, it's integration with the partner. It's just 158, 155 like, pages. So it's pretty much like very like, short book like that we can use to more like revise the curriculum, revise the content, from the SDA point of view, actually. So you can refer to this book as well. This book is also like pretty much okay. So then like, let's say, for example, we have to do some software upgrades or so, or some official like, Cisco Live events, they basically go on. And so here is one document that we can refer to cover, like it is a 600 page, like more like a PPT kind of thing that covers everything regarding the SDA. So this is one document. How to do the software upgrade? This is one document. So like, we have plenty of documentation that we can refer to when it comes to completing the content. We'll stay focused on the things that we have to cover as a part of content, but we will also like refer to these other documentation, such as whenever we have to do the software upgrade, whenever we have to, for example, refer to like some specific documentation, we can always go to the Cisco website and download or maybe refer to the documentation from there. So we'll keep doing it throughout the content. Whatever documents are necessary, those documents will be uploaded on the portal, and you can download it directly from the portal. Whatever documents are necessary to complete our classes, all those documents will be there, will be uploaded on the portal. Again, at the same place from where you have joined the classes, you can download all these PDFs, documents, and you can keep it with you, and you can refer to it as our content progresses. Then other documents are there as well. Whatever documents are needed, either we will refer it directly from Cisco website, or and you can download it directly from Cisco, or you will get those from the portal itself. So no need to worry on the documentation, right? So for the books, when it comes to documentation, documentation can be referred to from the official Cisco website or the portal. We can now, the most important thing, like I said, like I will do all the labs and everything. I have some physical equipment here. We have some 9300 series switches. We have some 3850 series switches. So we have some WLCs. We have some APs. We have a DNA center as well. So I will be able to do all the practice and everything. I will be able to do all the practice and all. I will be able to show you all the things as our content goes on. From the very scratch, we will discover the devices. We will add them in the DNA center inventory. First of all, we will set up the DNA center from the scratch itself. What things we have to do when we just install the DNA center. In fact, how to install the DNA center when you get a DNA center appliance, that we will talk about as well. It will be in very much detail, so no need to worry on that. So the main point is that I will be able to show you all those things, everything from the scratch, like but since it is not possible, like to implement these things virtually. So that will be a problem. Yeah.
So do we have like will we get the lab access or
Yes,
not?
no. That's the main point. As long as the classes are going on, so the lab access will not be possible, because all these are physical equipments. In order to provide the lab access, like the remote has to be set up, and then candidates can do the lab. But then the next day, I will have to reset everything. Resetting the DNA center again and again will take like a lot of time, and it might crash. And also, lab access actually, unfortunately, at the moment is not possible. That is the one problem that we have. And you can't do these things in a virtualized environment, such as even GNS. You can't do all those things in those platforms. You don't have the support of DNA center controller in the EVE-NG. You do have the support of Catalyst 93, 90, 92. You have the support of Catalyst 9000 series switches in the EVE-NG nowadays, but that requires way too many resources. I have observed that if you want those Catalyst 9K series switches to operate properly, one switch at least will require 24 GB RAM. Like for a proper smooth operation, otherwise you will continuously get the messages of CPU hog. So 24 to 32 GB RAM for one particular, like for one Catalyst 9K series device, we will have to provide.
So, but is it possible to create a lab if we have like enough resources in the like?
For when it comes to like enough resources, and Cisco does have like an option of VDNAC, DNAC V, DNA Center V, virtual DNAC, with that you can deploy in a virtualized environment such as ESXi. But the server that you require for that is going to be like, the server has to be powerful. You should have at least 512 GB RAM. Then at least you will have like 40 to 44 core CPU, and then at least like 4 to 6 TB SSD, server grade SSD, because it checks the throughput and all. When the DNA center, when you install the DNA center, it checks the throughput. Like, if the read write speed and the throughput of the disk is not matching, it will just not install.
Okay.
So if we have like a well-equipped server, then it is possible to implement that. It is possible to deploy that DNA Center virtual appliance on the ESXi server. People have done it. People have done it on the less resources as well. But the problem is that when you keep doing things on the DNA Center, you will notice that it will sometimes it does not respond. Sometimes like the GUI hangs. Sometimes like it takes a long time to execute a particular task. So those kind of challenges you will get if you provide like less resources. So like in short, it will not be possible for you to practice everything that we are doing in the classes alongside with the training. It will not be possible for you to do like all these like things from the lab content. However, you can repeat almost everything. I'm not saying like everything, but I will say like I will say 60 to 70%, even 75% thing you can repeat. You can still do on Cisco D Cloud.
Okay.
So they do have on the Cisco D Cloud. They have an always on. They have one always on DNA Center. It's always on. You don't have to do any reservation also. It's always on. You can log into that DNA Center at any time, and you can just directly start doing things on there. Again, I'm not saying that you will be able to do everything there, but from our content point of view, since they use a fixed topology, they already have a lot of devices added in that. They already have created the fabric and all. But you can always create new sites. You can always create a new fabric in that cloud delivered D-Cloud DNA Center. Let me show you. So just go to the Cisco D Cloud and just log in with your Cisco credential. Like just visit the Cisco D Cloud. Here is the Cisco D Cloud, and I'm going to just log in with my Cisco credential here. So I'm going to log in with my Cisco credential here. So I have logged in with the Cisco credential on the Cisco D Cloud, and now here we have like old version, new version. We have both the versions of the DNA Center that you can practice on. So this is Cisco D Cloud. From here, you can at the very top, you can choose your server. You can choose the server. You can choose like US East, US West, EMEA, Asia Pacific, or whatever. So I have selected like US East. Then I will go to the catalog, and on the catalog here, either you search on the catalog, either you search right here the DNA Center, either you search here the DNA Center Catalyst Center. You search here. Otherwise, you just D Cloud, then instant demo, D Cloud and instant demo, and just scroll down. You see DNAC, just scroll down. So it is published very recently, like 7 February 2025. I have not even checked it. Let me check it. What is this? Scroll down. Here is Cisco Catalyst Center Automation Assurance 2.3.5 instant demo. Just view it. Click on this button. Then scroll down 2.3.7 instant demo. Click on, like, either you click on the view button or click on here. If you click on this link, it will open the details about that demo. Here is 2.3. What is the username, password to log in, the latest graphical user interface and all. What are the things that are available. So whatever, like, just click on the view button, and it will basically show you. It will show you, like, here is, for example, a login page. This is the Cloud DNA. This is not on my premises. This is the Cloud DNA. You can log into this DNA Center. You can log into this DNA Center as well. You can log into these different versions of the DNA Center that is available on the D Cloud, and it is not going to ask you for like any charge or so. You just have to select the correct data center, and from there you can just start using the DNA Center right away. Like, it's an always on DNS. Sometimes it works, sometimes it does not. So, sometimes when there is a lot of load, it might load slowly, or it might not even load like this. But in most of the cases, you can see here is a home. We already are in the DNS center. Here we can log in with the DNS center with the same demo 1234 username password. Once you log in, it will basically like show you. It will show you like all those things from the DNS center point of view. You see, so Catalyst Center, number of devices, 79 number of devices, for like, all these things basically. Then you can just, then you can explore each and every option. You can explore each and every option. You can explore all the options that we have here in this DNA center. Like we can, in fact, create, if let's say, for example, you want to do some changes, design, let's say, for example, you want to create a new site or so, you can do it. Like, for example, you can go to here, you can go to add area, you can call it like India, for example. So it's not read only, by the way. It's not read only. It is both read and write. So India, then add building, for example, like, so it's both read and write. Like it's read and write both. So we can add the buildings, we can add the area, then we can go here, explore the network settings tab. We can define like different servers information, like who is our ICE server, who is like the HCP server, who is like the DNS server domain name. We can define define the device credentials and everything, IP address pools and all, wireless. What I'm trying to say is that we can do like plenty of everything. Like we can create an IP address pool. It will not be the exact same thing that I will be doing here, but you can repeat like most of the things in this virtualized solution to get yourself familiar with the user interface, where each and every option is there, how to do this, how to do that, all those things definitely you can do everything. Like, it's read and write both. So you can go to the wireless, you can go to the telemetry, security and trust. We can do a lot of things basically from here. We can go to the policy tab, we can create the scalable group tags, we can create the good base access control policies. Then we can go to the provision tab, we can create our SDA network. It's not read only, it is read write both. We can create a new, like for example, create a new policy, for example, from here. We can create new security groups. It's not like we can't, like HR, like, 8 a.m. Something like that. It's not read only, it's read write both. So I was able to create a security group, scalable group called HR 8 a.m. The security group was created successfully somewhere. Then I can go to the policy, and then I can create the policy. This is our security group. I can create the policy as per our requirement. So it's pretty much like, again, I'm not saying that you will be able to do everything, such as, for example, you will not be able to discover a new device. You will not be able to configure the fusion router, but those things you can practice on the eve. Those things you can practice on the eve. On, like, when we do the, for example, fusion router configuration, whatever things we are doing, you just create a scenario in the event G, and then you can practice on the eve. I'm not saying that you will be able to practice like everything, but a lot of things, like 70-75% thing, even more than that, you will be able to practice in this virtualized environment. In fact, 2.3.5 works even better. At the moment, it's not working, but this 2.3.5, this version works much more better than this 2.3.7. But anyway, so this is also working. Since this is the latest version, it is also working like properly. So we can do plenty of things from here. So just whatever things we are doing in our classes, you can just visit the Cisco D Cloud and try to repeat those things. Whatever things we can do in the D Cloud, you can repeat those things on the D Cloud, and then try to get yourself familiar with the user interface and different concepts of the SDA. Honestly speaking, that is the most that you can do when it comes to lab. Or you can, if you want to set up things like from the scratch and all, then there is this thing called DevNet Sandbox. So either you use this always on D Cloud, DNA Center, and practice like almost everything that we can do. You will be able to practice like a lot of things, but otherwise you can go for a DevNet Sandbox. You can go for like a DevNet Sandbox, but when it comes to DevNet Sandbox, it's not going to be an instant demo. You will have to schedule the lab. And then at your fixed time, you will log in with your credentials provided by the this sandbox environment, and then you are going to do the labs on there. Basically, you will have to have the VPN, like any correct VPN you will download, and then some credentials and all those things will be there, and you can practice things on there as well. But I have heard that the DevNet sandbox also is not like very much stable. Like that the user interface is not proper. It does not work properly. It hangs a lot. So those challenges are still there actually in that DevNet sandbox has. But apart from that, if you want to set up things like from the scratch, then DevNet sandbox is basically you can refer to. Let me, for example, you search DevNet sandbox. Click on this Cisco DevNet Learning Labs Center or sandbox environment. Just open it here. Here we have, or maybe I can just directly open Learning Lab Center. Here you will get like a lot of labs. Like here you are going to get like a lot of labs, and those are going to be like again free, but you will have to schedule. Like you will have to schedule these labs like before, and then you can practice at your schedule time. That you can do, but remember that it is not going to be like a very smooth experience. Like it is still going to be like there are going to be some challenges actually, right? So from this Learning Lab Center, from here also you can learn the technology. You can do the labs from here itself. So networking, Catalyst Center, SD-WAN is also here, but here you will have to schedule the labs. It's not going to be like so here for introduction to Cisco DNA Center REST APIs, there are like 4 labs, 1.5 hour. It will require that. These options are there. Here we can reserve our Catalyst Center always on, or we can schedule it. Let's see how it goes. We can reserve the sandbox, or we can visit the always on DNA Center. But as you can see, like it sometimes does not work properly. So still it's loading. So a much more better option will be just to refer to the Cisco D Cloud to repeat everything that we do in the lab. You will be able to repeat almost everything, not everything, but you will be able to do like again 70-75% I will say content you will be able to do in this D Cloud DNA Center. Again, you will not be able to do everything, but you will be able to do like a lot of things on here on the cloud delivered DNA Center, this one. And it is, since it's the latest version as well, it's the latest version actually. Where is that help one about? It's like 2.3.7.6, which is the latest one. So you can get yourself familiar with the user interface and do like plenty of labs. So that option you can. Otherwise, you will have to have a big server where you can download the DNA Center vDNA Center image, which is approximately 30 to 35 GB. 30 GB, I guess, image is there. You can visit the Cisco website and you can download it from there. Then you will have to install it on the virtualized environment such as ESXi. That virtualized environment must have sufficient RAM, then SSD, server grade SSD with proper throughput, and the CPU. If you have like 10, 12 CPU, 24 CPU, like it will not work properly. I have seen it like your web user interface, like web UI access is not present actually if you have like less CPUs. So the services basically does not run if you have less CPUs actually. So at least as per the documentation, it says that the DNA Center appliance comes with like 44 cores. So at least you will have to have like 24 to 32 cores. At least you will need to have to make it work properly. And let's say you deploy the DNA Center. Let's say that you deploy the DNA Center in the virtualized environment such as ESXi. What are you going to do with it? Where are the switches? If you plan to deploy the switches in the ESXi as well, maybe in the EVE-NG, you are planning to deploy it on the ESXi as well, definitely you can do it. But remember that in order to create a simple fabric site of 4 devices, you will require an additional 24 one Catalyst 9200 9K series device in the EVE-NG consumes at least 24 GB RAM. 24 GB RAM. I'm not too much sure about the CPU resources. I guess it is like 4 CPU. It consumes like 4 CPUs approximately. If I'm not wrong, might be like more than this, but at least 4 I remember. So at least like 4 CPU for like 4 devices. So 16 CPUs and 24 multiplied by 4, 96 GB additional RAM, and then like 16 core. So it gets more and more and more complicated. You have to have a server with a very big resource, like at least 512 GB RAM, at least 40 to 44 physical core, then at least like 4 to 6 TB server grade SSD, with proper throughput and all. The CPU must be like, from the proper version as well. Then only you will be able to implement the DNA Center V and the even G along with all that. And then you will be able to do the practice on the home environment. But it is not going to be a very feasible solution, honestly speaking. And why we can't provide the labs? Because in order to do the labs, what candidate, like let's say there are 3 candidates who want to do the lab. And let's say we have reserved a slot for the 3 candidates. Let's say 8 to 12, 12 to like, let's say, for example, 4, and let's say 4 to 8. Now, the problem is that when this timing ends, we will have to reset like the DNA Center. When I reset the DNA Center, in order to enable the services again, it might require 1 or more than 1 hour. So every time someone ends their lab, someone has to erase all the configurations done on the physical switches. Someone has to, wipe the DNA and reset it. Once you reset the DNA Center, it needs at least 1.5 hour to make all the services up and running. Otherwise, this kind of a warning will be shown to you that some services are not running properly. Like this, I'm getting this warning. I just restarted it, I guess, sometimes back. So I'm getting this warning. So that some services are not running properly. So it gets more and more complicated. That's why at the moment, lab access for the DNA Center we are not. So you can be dependent. You can actually practice on the D cloud plenty. Like you can practice a lot of things on the D cloud. I'm not saying that we'll be able to practice like everything, but most of the things we'll be able to practice on the Cisco D cloud. A few things we will not be able to do, such as discover the devices and everything. But for those things, you can definitely refer to the recordings, the documentations, since I will explain each and everything one by one. So it will not be a problem. It should not be a problem. But this is the approach for the lab. This is how you are going to cover the labs. It will still be like a very fruitful classes, because from the technology point of view, you will get the technological understanding. You will get the concepts. You will get the idea on the terminologies, the commands, the verification commands, the user interface and everything. So still it is going to be very much fruitful, but it's completely on you, completely up to you, how you are going to decide. This is the approach that we are going to take for the lab. You can completely be dependent on the D cloud. You can practice plenty of things on the D cloud, not all, but you can practice like a lot of things on the D cloud, and it will work. You can set the roles and all. By the way, let me show you, just in case if you still have some doubt. You can go to the Fabric site. You can open the Fabric site that they have created. Like we have multiple devices here, and you can set up the roles and everything on this particular site. You can practice on this version, or you can practice on the older version if you want to. But if you want to do the things from the scratch, then you will have to reserve it from the sandbox environment. But it might work, it might not work, might be available, might not be available. That you have to see. It does not work properly always. So just explore all these options. You can explore all these options and see what things you can do here, what things you can do here. So, for example, we can start the lab. You can just follow it, right? So this is the approach for the lab. You can repeat the things. You can repeat the things on the Cisco D cloud. You can repeat the things on the Cisco D cloud. Plenty of things you will be able to do on the Cisco D cloud. But if you want to do the labs completely from the scratch, either you will have to have a big server where you can practice all those things. Else you can use the DevNet sandbox. In the DevNet sandbox, you can do plenty of things as well. But again, it might work properly, might not work properly. That a little bit dependency on the D cloud we will have for our lab. I will do everything on our premises, hardware devices that we have, DNA Center that we have. But for the rest, you will have to be dependent on that. Let me know any doubts. This is everything that we should know before we begin our technical discussion. These are all the basic things that we had to talk about. This is done. Any doubts, any questions you have regarding the content? Yeah, let me know. Any more questions from the content? Anything that you need to clear before we begin our content? This is what we are going to cover. And again, this is not going to be a beginner level classes. Just to be very clear, you have to have some prior understanding of things, such as you have to know before our SDA classes, you have to have the knowledge of what is like this routing, what is this switching, what is IP address, what is VRF, what is like route target, import, export. We'll talk about it, but what is BGP? What is this BGP in AS number, neighbor, IBGP, EBGP? You have to have the understanding, basic understanding of these protocols, terminologies before you begin your classes. What is OSPF? What is EIGRP? This basic routing and switching idea you will have to have. It's not that I'm going to start from the routing or switching. You have to have the idea about the routing. You have to have the idea about the switching, the two-tier design, the three-tier design, collapsed core, core distribution access and all that. You have to have the idea on that. Our content is going to focus specifically on the SDA, assuming that you know about the traditional network, at least a little bit. If not in very much detail, at least a little bit you know about the traditional network, where routing works, where switching works, where do we perform the routing, where do we perform the switching, where we create the VLANs, where we configure the trunk, all these, what is the two-tier design, what is the three-tier design, what is this concept of BGP, what is EBGP, IBGP, neighborship, VRF, address family, IPv4, then route target, import, export. These things you need to have at least the basic understanding of. I'm not talking about Lisp. I'm not talking about the VXLAN. I'm not talking about Cisco TrustSec. I'm talking about the traditional basic things we have to have the idea. Like if you ask me what is the distribution layer, I'm not going to explain. I'm not going to explain it in very much detail that what is the distribution layer. When we design our network, we will talk about it, but I'm not going to go in very much detail of the distribution layer, the properties of the devices that we connect at the distribution layer and all that. No, we are not going to do it. For that, refer to the switching classes. For example, when we are doing the BGP configuration on our Fusion router, I will not explain what is BGP, what is this neighbor IP, what is this remote AS, what is this network command, what is this redistribute thing. These things you should already have the idea of. If you don't have it, make sure that when our content reaches to that point, make sure that you at least have gone through from some videos, gone through some documents, and you have at least covered the basic things according to those protocols. So it's not going to be a complete beginner level classes. Some technical understanding you already have, it will be assumed throughout the content, and we will start our content based on the same. Actually, anything, any point that you want to discuss, let me know. Any expectations, anything. We will explore all the options that we get in our DNA Center, of course. Not all, but again, as per our content and some wireless, AAA, all those things, we will definitely talk about. We are going to explore all those options. We will do it. But yeah, it's not going to be from complete scratch. So first thing first, why do we require software-defined networking? What are the challenges in a traditional network, and how to overcome those challenges, how this traditional network, or what challenges basically are there in the traditional network, and how the software-defined networking is going to help in overcoming those challenges. When we talk about challenges in a traditional network, there are, remember that the devices that we use in the traditional network, such as, for example, routers, switches, firewalls, we use plenty of devices. If I talk about routers and switches, let's say from the routing and switching point of view, whatever devices we use in a traditional network, let's say we have one, let's say, for example, we have two, and let's say we have three devices. They are connected like that. These three devices have their respective, they have separate control plane, data plane, and management plane function. They have separate control plane, data plane, management plane, control plane, data plane, management plane. Every device has its own set of control plane, data plane, and management plane functions. Every device has its own set of control plane, data plane, and management. What is a management plane? Management plane of the device is responsible to deal with the device management, how the device is being managed, how someone has taken the access of the device, and how the device is being managed comes under the management plane function. The part of the device that is responsible to handle the device management is what we refer to as the management plane. management plane of the device is responsible to manage a device. Like device management is handled by the management plane of the device. So when we, let's say, for example, do telnet, when we do the SSH, we use SNMP for the network management. We can use plenty of ways to push the configuration on the device or retrieve the information from the device. All those things are basically considered part of the management plane function. So telnet, SSH, console, auxiliary. When we connect the device using the console port, we connect the device using the auxiliary port, then we do the telnet, we do the SSH, we use SNMP for monitoring purpose and all these things like are considered part of the management plane function. Management plane of the device is responsible to deal with the device management. And since everyone has their own set of management plane, so if you, let's say, for example, have to configure, manage this device, then you will have to connect to the management plane of this device. Then if you have to perform the management of the router number 2, then you will have to connect with the management plane of router number 2. And if you want to do some management on router number 3, you will need to take the access of router number 3 and then do the configuration changes or whatever changes you want to do on router number 3. Since the management plane is separate on each and every device, we will have to do the management one by distributed management plane we have. Since we have a distributed management plane, each and every device needs to be managed separately, one by one. Device management, box by box, device management needs to be, which of course is a challenge. Taking the access of each and every device one by one using telnet, SSH, console and all, it is going to consume like a lot of time. Then you are doing the configuration changes on this device, then on this device, then on this device manually. There are chances of configuration errors and all. So like there are a few challenges managing those devices one by one individually. So yeah, that is like the management plane is basically distributed. Then we have the control plane on the device. Control plane is basically responsible to control the data plane, how the data needs to be forwarded, whatever tables are required to perform the data forwarding, like for example, routing table, ARP cache, if it is switch, then MAC address table, STP, OSPF, EI, GRP, all these things, all these protocols run at the control plane of the device. Control plane basically means the CPU. Control plane operations are more like CPU-centric, CPU-intensive operations. Control plane of the device, control plane is more like the brain, control plane is like the CPU of the device. Control plane operations are CPU-centric operations, basically. So if, let's say, for example, you want to configure OSPF routing protocol, just so the routing tables can be updated, you not only need to configure the OSPF routing protocol to run on router number 1, you will also need to configure the OSPF routing protocol on router number 2 and on router number 3, because this device has its own control plane, this device has its own control plane, this device has its own control plane. We do have distributed control plane. So once everyone runs the OSPF adjacency will be formed, database will be exchanged, and then a routing table and everything will be distributed control plane. Control plane is part of the device that is responsible to maintain, create, populate a variety of tables that are required to perform the data forwarding. Control plane controls the data plane. Control plane instructs the data plane on how the data should be forwarded. And the data plane on the device, effectively data plane of the device, it is responsible to perform things such as decapsulation, encapsulation, routing table lookup, ARP cache lookup, MAC table lookup. All those things are done. Then when the data arrives on a certain port, the data is decapsulated. Then variety of table lookups are done. Then the data is encapsulated, forwarded to the next device. All those functions are of the data. Data plane is responsible to actually forward the data. Data plane is actually responsible to forward the data. Data plane is responsible to forward the data. Data forwarding, things such as encapsulation, decapsulation is done by the data plane of the device. Now the challenge is, each device that we use in a traditional network has its own set of control plane, data plane, management plane. We follow some sort of distributed architecture. We have distributed control plane, we have distributed data plane, and we have distributed management plane. That is why, since there is no centralized control plane, it's not possible to run a common protocol across all the devices just once and everything can be, and all the routes and all those things can be populated automatically. It's not possible. Since like everyone has its own management plane function, each and every device needs to be managed individually. It's basically not possible, like, to access or manage all the devices at once by just using some sort of like tool or so. And since every device is having its own data plane, so what tables this device is going to be referred to has nothing to do with the tables that this device is going to refer to, has nothing to do with the entries in the table that are available on the route number. Everyone must maintain the proper routes. Everyone must have the routes in their respective routing table. Everyone must have the entries in the ARP cache. Everyone must have the information available in the MAC address table maybe. Everyone must maintain the information individually, then only proper forwarding will take place. So one challenge that we have in the traditional network is that it follows the concept of distributed architecture. In the distributed architecture, every device has its own set of control plane, data plane, management plane. So if the control plane of the device goes down, then the tables that are populated by the control planes will be flushed as well. And then as a result, data forwarding will also not happen. Some sort of distributed architecture, since we have, each and every device needs to be managed individually. Every device must have the routes available in the routing table, ARP cache, STP database, and the MAC address table and whatnot. So everyone must have the information available in those variety of tables, and then only the packet forwarding will happen. So this is one of the challenges, that the traditional architecture follows a distributed control plane, data plane, management plane concept. The architectural planes of the device are distributed across multiple devices, with everyone having their own set of the three architectural planes, which is why we need to manage all the device. We need to run the protocols such as OSPF on all the device. Every router in the network must have the route available in the routing table, their own routing table, so that the data forwarding can happen. It's not like router 2 is going to take a look at the router 1 routing table or router 3 routing table. This is one of the challenge that we have, distributed architecture, because of which like the device management, configuring the protocols, troubleshooting the data forwarding process one by one on each and every device gets a little bit complicated. Second challenge that we have in a traditional network is with regard to, again, management. Not only we have wired devices in the network, we also have wireless devices in the network nowadays. We have like different security appliances. We have like access point. We have WLCs. We have routers. We have switches. We have different types of like devices. For wired devices such as routers and switches, for the wireless devices such as WLCs, access points and all. Some users are connected via wired network. Some users are connected via wireless network. We need to configure some policies. Let's say we need to configure the policies in our network to control what users can gain access to what part of the network. We will need to configure the policies for our wired user, and we will need to configure the policies for wireless user. We might want to implement the same policies for both wired and wireless user, or we might want to implement different policies for the wired and wireless user. But the point is that for the wireless users, the policies we are going to create with the help of a centralized controller such as WLC. We are going to use the concept of identity services engine, AAA, ICE, and all those things we are going to use. Basically, we will need to create different policies for wired and wireless user. We need to manage like wired infrastructure and wireless infrastructure along with the security appliances and other appliances used in the production environment. Management of all those devices, again, one by one. Management of the wired infra and wireless infrastructure, again, individually is going to be a little bit problematic as well. Not to mention that our company might not even use the single vendor. The company might use different boxes, such as company might be using some Cisco switches, company might be using some HP devices, company might be using some Huawei or Alcatel, or basically like different vendors company might use. In Cisco devices, for example, when we configure the STP, it runs as a PVST, per VLAN spanning tree, rapid per VLAN spanning tree. But in other vendors, it is just a spanning tree protocol. So how are we going to perform the interaction between the PVST and STP, and how are we going to manage this thing effectively? that who is going to become, for example, the root bridge, what port are going to be the root port, what commands we have to execute here, what commands we have to execute here. So if your company is not even using a single vendor, if your company is using like multi-vendor environment, if it is there, then you will have multi-vendor devices to manage. The approach of managing like one vendor device might be different than the other vendor. So if you have like multiple vendor devices, you will be managing those devices like individually using different approaches, which will again going to increase our management challenges in the production environment. We have to manage the wired infrastructure. We have to manage the wireless infrastructure. We have to create the policies for wired devices. We have to create the policies for the users that are going to connect using the wireless technology. Then we have some different vendor devices. We have to take the access of those devices, fine tune things such as STP, RSTP, or whatever. Some protocols are not even running on the other vendor devices. So make sure that we don't use those protocols in a production environment. Managing the multi-vendor environment, managing the wired and wireless network one by one, individually, box by box is going to be, again, it is going to impose a little bit challenge. Management challenges will be there. And then someone says that something is not working. Someone says that, okay, you did everything, but someone says that something is not working. And now you have to T-shoot what things are not working actually. You have to T-shoot, you have to log into Cisco devices, you have to log into the HP devices, you have to log into the WLC and see what things are working, what things are not working. You must get from somewhere, you must get the insights. You will execute some T-shoot commands, like you will check the logs, you will check the SNMP messages on device by device basis to identify what exactly is not working, what exactly is the problem. So operational challenges like T-shoot, like troubleshooting, like, you will have to perform on day-to-day basis as well. And doing the troubleshooting or solving those issues like one by one is going to again consume time and definitely the resources. So operational challenges are also there. Once the network becomes operational, plenty of issues might arrive, and then administrator will be responsible to resolve those issues as per their technological understanding. And if they are not able to do it, then escalate it to the upper level, for example. And since we have a multi-vendor environment, it is possible that we need to execute different commands on different vendors to make things properly work. So, operational, accidentally you executed some Cisco type command on the HP devices, and of course the syntax was not accepted. So, T-shoot in a multi-vendor environment is also going to be a little bit complicated. Operational challenges will be there. There will be plenty of like operational challenges. There will be like management challenges. There will be like operational challenges. There will be challenges because like the devices follow the distributed architecture. There will be a challenge on deploying a new device. Deployment challenges. So if let's say you have to deploy a new device, if you have to deploy, let's say, for example, a new device, then like what configuration? Let's say you have to deploy a new router. Then what configurations we have to do on that router from the device hardening point of view, what DMVPN configurations are needed to be done, what are the IP addresses on the interface. Even though you just copy and paste the configuration from one device to the other device, still like it is going to take some time to make a device completely up and operational after the deployment. So when we have to deploy a new device, such as a router or a switch in a production environment, it might consume some time and resources. Deploying a new device, making it completely operational in the production environment is going to, again, of course, consume some time and the administrative resources. So deployment, you did everything, you copy pasted everything, but you forgot to change the IP, you forgot to change the router ID, and suddenly your OSPF neighborship is not coming up, or your BGP neighborship is not coming up. And you pasted the configuration on like tens of devices. So like 10 devices you had to deploy, and you just copy and pasted the configuration on 10 devices, and you forgot to change the router ID. So all those 10 routers having the same router ID, and none of those routers are trying to establish none of those routers are able to establish, let's say, for example, a BGP connection to the neighbor router. So you will now need to log into all those 10 devices, and then you will need to change the router ID manually. So again, when it comes to deploying a new device, everything you have set up properly, but your DMVPN is not coming up. Why? Turns out that on some routers, the exit interface is fast Ethernet or gigabit Ethernet 0 by 0, and on some routers it is 0 by 1. and you forgot to change the tunnel source on while copy pasting the configuration. You pasted the configuration on 10 devices, and after the password there was a space, and now you are not able to log into the device because the incorrect password got pasted. Basically, like when we have to deploy a new device, and even if we are doing the copy paste, from one device to the device, it will still add a few challenges in the network, such as like even after doing everything, your tunnel is not coming up, your OSPF membership is not coming up, you are not able to log into the device. Plenty of challenges even after the deployment of the device will come. You will have to deal with those kind of challenges as well. Deployment related challenges you will also have to deal with. And the most important challenge that we have is the security challenge. Security related challenges. We can enforce the security, we can control basic. When it comes to enforcing a basic security, we can configure things such as like VLAN at the switch level to control what two devices can communicate and what two devices cannot communicate to each other. We can also configure things such as access control list or ACLs to control what two devices are supposed to exchange the data and what two devices are not allowed to send and receive the data. In the classical network, in the traditional network, we can in fact enforce the security with the help of the ACLs and VLANs. But ACLs and VLANs, enforcing the security based on the access list and the VLAN, it is not going to scale very well. Why? Because we have limited number of VLANs, 4094 only. Then we have like ACLs. We can configure the ACLs. Okay, fine. We can configure standard ACL. We can configure extended ACL. But remember, ACL can have like thousands of lines in one single ACL. We can have like thousands of statements. The problem is that adding or removing a new statement in the access control list in a production environment, in a live production environment, will always have some risk of damaging the network. Accidentally, like I'm not saying like purposefully, but accidentally, if you are doing an edit in the ACL in the live production environment, and accidentally if you make a mistake, then it will harm the existing infrastructure traffic. ACLs are good, but they're not very much scalable. How are we going to enforce the security that is not dependent on IP, that is not dependent on the specific configurations of the VLAN and all? How are you going to enforce the security for the wired user and the wireless user, for example? So some security related challenges are also going to be there. Some security related challenges will also be there. So we have like deployment challenges, we have operational challenges, we have management challenges, we have security challenges. Since we have the distributed architecture, we have to manage all these devices individually, configure the routing protocol, switching and all those things individually on the boxes. We have to make sure that every device is able to forward the data by encapsulating, decapsulating. So that challenge is also there. Some particular device is not able to forward the data. Then we have to also find out like why the encapsulation or decapsulation is not happening. What if if you have multiple vendor devices, then how are you going to manage those multi-vendor devices? How are you going to take the access of a Cisco device, configure STP, then the HP device, then configure the STP? How are you going to make those things work properly? Plenty of challenges are good. And let's not even talk about things such as, I'm talking about from the LAN point of view. Let's not even talk about like the cloud. Nowadays, like the adoption of the cloud is like in very much fashion. Like companies are moving their softwares in a cloud. They are moving their infrastructure in a cloud. Basically, they are using these different types of service. Although the trend has changed a little bit, but companies are deploying their applications on the cloud and calling it like software as a service. Companies are moving their infrastructure on the cloud. And they are calling it like infra as a service. We are providing the infrastructure as a service. How are we going to connect our enterprise infrastructure? How are we going to connect the enterprise network with those cloud delivered services such as SaaS applications, such as infrastructure as a service? What about like we have our own private cloud? Like here is our own data center. How are we going to perform the communication? How are we going to access the resources that are available in our data center in a secure manner, in a secure fashion? Let's not even talk about the addition of the IoT devices in the network, like the CCTV cameras, the sensors, the pagers, the speakers, and all those different IoT devices that we have nowadays in the network. Can we control like what devices can communicate with what devices in that case? Basically, the list goes on and on and on. So in a traditional network, like we do have like a lot of challenges. Companies use different approaches. Companies use different tools to overcome these challenges. Companies might ask the developers to create some tools specific to their organization, and then you practice on those tools. You use some SNMP monitoring softwares. You use some net flow collectors. You use some in the production environment. You work on variety of tools to observe what is going on in your network. And let's say someone raises a ticket, then you are able to see the issue, and then you will be able to resolve that issue as per your technical understanding. Otherwise, escalate the issue to the higher teams. So companies might use different tools, but how efficient are those tools? Like we have different tools for different operations. Like we have different tools for configurations. We have different tools for management. We have different tools for configuration management. We have different tools for different things. Working on different tools, different tasks is also going to put some administrative overhead. So that is also there. There are, what I'm trying to say, there are plenty of challenges in the traditional. If like, and you know, if it's okay, but some sort of like provider organization, if you are some sort of like provider company and you are responsible to provide the services to the customer, and on regular basis, customers are giving you some requirements, then and you have to do the changes in your environment one by one again and again. So that is going to add additional challenges, additional overhead. The list goes on and on. If I summarize, if I like categorize these challenges, there are many challenges in today's network in managing the network because of manual configuration and fragmented tool offering. We mostly do the configurations manually, but we use different tools to perform different tasks. Manual operations are slow, error prone, and they are proving to be ineffective in a modern day network. Earlier, humans were the only users of the network. But nowadays, along with the humans, machines are also the users of the network. Softwares are also the users of the network. Earlier, the humans were like fixed at a particular location, but nowadays humans are mobile. Like, you know, they are roaming from one place to the place. With the growth of the users and different devices types, such as we have like mobile phones, such as we have tablets, such as we have laptops, such as we have servers, such as we have some CCTV cameras, sensors. We have different types of devices in a modern day network. Configuring user credentials, maintaining consistent policy across the network for all these device types for both wired and wireless network will get more and more complex as you introduce like more and more different types of devices, different types of users of the network. The rate at which the change is happening basically exceeds the human scale. The rate at which the changes can be done, it basically is slower than the rate at which the changes are expected. The pace of change exceeds the human scale. Basically, we have some network operation challenges and we have some security operation challenges. If we categorize those challenges that we have discussed about, we have network operations related challenges, and then we have security related challenges. The engineer, the network engineer, the engineers like the IT admins, the engineers, they must be ready to take the customer's requirement, take the client's requirement, and do the changes basically as soon as possible. Network might not respond quickly to evolving business needs if the changes are needed to be done manually. Such modifications might take a long time, and of course, they will be prone to error. If the customer says that we want to do this particular task in the network, and you are doing that task like manually, you are executing some commands, there are very good chances that some configuration errors might be there. Effective network segmentation can be exceptionally difficult to achieve in a complex network with variety of users and devices requiring different access privileges. We have different types of user, we have different types of devices. Different users have the access to different devices. Configuring the policies, configuring the access privileges for different types of user for different devices will get more and more complex as things go on. Traditional IP-based methods using firewall, VLAN, ACLs, they do not scale well, and they are not efficient in responding to the real-time requirements. Bottom line is that the networks of today, they do not address the today's business needs. effectively. As per the study done in 2016 by Cisco, approximately 3:1. The ratio of operational expenses to the capital expenses on the network operations, labor and tools is approximately 3:1. We spend more and more resources, we spend more and more money on the operational expenses. Like, operating a well-established network, we spend like more and more money to make it up and running. 95% changes are done manually. 75% of operational spends on changes are spent on changes and troubleshooting only. 70% of the policy violations are due to human errors. So these are some issues that we face because of those challenges that we have in the traditional, in both enterprise network and in the data center or in the service provider network. So hence they thought of a solution. They thought like, why don't we use a way to overcome these challenges? Why don't we use some, instead of using a human, instead of asking a human to configure our network, why don't we ask some software to configure the network? So came in the market the software-defined networking, where a piece of software is going to configure and manage the network resources. It is going to configure and manage the network devices, as opposed to a human, which is going to be less prone to error. Changes can be done at a fast rate. We can do the troubleshooting monitoring from the same point. So a lot of advantages we get when we do the management of the network from a centralized point with the help of a software, rather than using like multiple administrators in the network. So software-defined networking is basically, we'll talk about it. Software-defined networking is basically use of a software to configure, provision, monitor your enterprise network. So different like, solutions, they use different softwares. We will talk about them one by one, like what data center uses, what like our enterprise network uses. We'll talk about that later on. We'll talk about like what software defined solution each of these like, types of network they use. Like, so these are some challenges that we have in the traditional network. Now we will talk about like how to overcome these challenges and what softwares Cisco created to overcome these challenges, what are their names and how they are implemented in the network. That we will talk about tomorrow. This is just the basic introduction, like what are the challenges in the modern day. This is just the introduction. We will continue from here tomorrow. We'll talk about like the options. We'll talk about by Cisco to overcome these challenges. So we had like different challenges. We had like a lot of challenges in operating the network, in securing the network, in managing and troubleshooting the network. So they thought like, why don't we, instead of using like humans to do all the tasks, why don't we use some machines? Why don't we use some softwares to do all these things, to perform variety of network operations, to do some deployment, to fix the operational issues that we have, to do the troubleshooting, monitoring and all? Why don't we use some softwares for the same? We are already using softwares for network management, network monitoring. We were already using the software. So they thought like, why don't we improve those softwares, or why don't we create some new softwares, also operate, also configure, also manage the entire network from one centralized. So the term software defined networking, or SDN, it refers to the ability of a software to manage the entire network from one central point. From one point, we can configure, we can provision, we can manage, we can T-shoot, we can operate the entire network of our campus area, entire network of our WAN, entire our data center, for example. So software-defined networking, or SDN, it uses software-defined is basically use of a software to manage the entire network, LAN, WAN, data center, maybe from one centralized point, and to be able to configure, manage, monitor, troubleshoot, and do all those variety of tasks from one centralized point. That comes under the SDN. That comes under software-defined network. So in software-defined networking, they to overcome these challenges that we discussed previously in the last class, they decided to use software-defined approach to manage the network, where the engineer, instead of configuring all these devices one by one, engineer is going to define its intent. What exactly they want to achieve? What exactly do you want to do? What exactly is your intent with the network? What do we exactly want to achieve from this particular network? It will define its intent on a software, and the software will be responsible to push all the necessary configuration. It will be responsible to push all the necessary configurations to make that intent work properly. So software-defined networking basically means the use of software. Software-defined networking is basically means like software-defined approach to manage the LAN, WAN, the data center network and all that. So that basically is what we refer to as SDN, software defined. So we do not need to do the configurations on the devices like one by one. We don't need to go on box by box and do the configuration on each and every devices one by one. Instead, what we are going to do as a network engineer, we are going to define our intent, what exactly we want to achieve from this network, what exactly is the objective of this network, what exactly we want this network to look like or perform like. So we are going to define our intent on that piece of software, and the software is going to take that intent, convert it into some valid configuration, and push those configurations on the devices. Whatever configurations are needed for the network to act as per the engineer's intent, those configurations will be generated and pushed on all these devices by that piece of software. Software-defined approach to manage the network, where engineer will configure its intent and software will automatically configure the devices based on the intent. So you do not need to, again, the advantage will be that you will not need to manage each and every device, configure each and every device on box by box basis. You will just define your intent, what exactly do you want to do on the software, and the software will configure the all these devices like automatically based on your provided intent. Hence the name software-defined networking. Software-defined approach to manage the LAN, WAN, and the data center network is what we refer to as the software-defined networking or SDN. So they created a few softwares. They created a few such softwares. They created a few softwares. Those were able to manage the network devices that we have, such as routers, switches, and all. They were able to manage those devices from one centralized point. They created a few devices. They created a few software. They created, like Cisco and other vendors, they did create a few softwares that were able to do that. And they installed those softwares. They installed those software on some, of course, like if you want that software to run, of course, like you will have to install that software on some sort of hardware. So here is a machine. Here is a device where that piece of software, which is responsible to manage our entire network, is basically installed. It is a hardware, essentially a server. It is basically a server. It is a server where that piece of software, which is responsible to manage our LAN, WAN, or maybe the data center network, is basically installed. Of course, like if we have the software, we have to install it somewhere in some hardware. The hardware must have some CPU. It must have some resources like memory. It must have some like SSDs, hard disk drives, so that it can store the database and all. Typically a server, basically where they install that particular software, and they connected that server in the network with the rest of the devices, such as like routers, switches, and all. And then this device, this server where we have installed that network automation software, the SDN software, this is basically made reachable to all the devices that we want to manage. I want to manage all these XYZ devices. So this device, this SDN software will be made reachable to all these devices. And then this software is going to perform all the configuration, provisioning, monitoring, and all those functions from one centralized point. This hardware where they have installed this automation, this SDN software, this resource, this server where they have installed that SDN software, they call it a controller. Controller is where that SDN software we have installed. The software which is responsible to manage the entire network from one centralized point. That software is installed on a hardware, and that hardware typically is a server with good amount of resources like CPU, RAM, and we call that a control. We call this as a control. SDN controller, software-defined networking controller, SDN controller to manage our LAN network, to manage our WAN network, to manage our, for example, data center. This controller is then going to be, eventually this controller is just a hardware where we have installed that SDN software, and then this controller, this piece of hardware is connected with the rest of our network, and it is made reachable to all the devices that we want to manage. And once the controller is reachable with all these devices, the controller will be able to do all the tasks. Controller will be able to, manage, configure, monitor, troubleshoot all those devices from one centralized point. And of course, for different operations, we have different controllers. Like to manage the LAN network, we have a different controller. To manage a WAN network, we have a different controller. To manage a data center network, we have a different controller. They could have created a single controller, maybe, but at the moment, we have different controllers to manage different types of network. To manage the LAN, also known as to manage a campus, a local area network, to manage a campus area network in a software-defined way, to manage a campus local area network, we have the solution provided by Cisco referred to as SD-Access. Cisco SD-Access solution. Cisco SDA is for the campus area network, typically to manage the local area network in a campus area. LAN switches that we have a variety of LAN switches at the access layer, distribution layer, core layer, and all. And we want to manage those campus LAN switches from one centralized point. That is what we refer to as that can be done with the help of the Cisco SDA solution. It is also known as SD LAN. Some other vendors have now also joined this particular market. So you might also see SD LAN solution from other vendors as well, which essentially will provide the same exact thing, but they call it like SD LAN. Cisco calls it like SD-Access, and some other vendors also provide the similar kind of solution, and they call it like SD LAN. So if you search on Google SD LAN, you will find like some vendor providing the same exact solution, but they call it like SD LAN. And eventually, SD-Access is the SD LAN. It is a software-defined approach to manage a local area network. So it is, in fact, the SD LAN. Cisco calls it like SD-Access for the campus area network. For the data center network, they have a different solution. For the data center network, they have ACIE. They have this concept called ACIE EPIC. EPIC, Application Policy Infrastructure Controller. EPIC is the name of the controller that they use in the data center environment. In fact, when you study like software-defined networking, you will notice that in the data center environment, the software-defined networking has been there for like very long. Application Policy Infrastructure Controller, or EPIC. EPIC is the centralized controller. EPIC is the controller that we use in a data center environment to manage the data center network from one centralized point. We have like different switches, Nexus series switches, and different like UCS devices, and all the different hardwares are available in the data center environment. And there comes the requirement on regular basis of the client to add some VM, remove some VM, add some resources, remove some resources. Like data center network is designed in a different way, following a different kind of topology and all. So in a data center network, when we have to manage the things from a centralized point, they have this controller called EPIC, Application Policy Infrastructure Control. Data center itself is referred to as ACIE. ACIE data center. ACIE data center. ACIE stands for Application Centric Infrastructure. Data centers are said to be built around certain services that they provide. Like, for example, storage services, or maybe like some certain business critical applications are running in the data center. Certain applications, maybe like FTP, TFTP, or you are responsible to store large amount of data in your data centers and all. Data centers are always built around certain applications that they serve. Hence the name application-centric infrastructure. Data center network is designed centric to the application that they basically serve. Application-centric infrastructure basically means that the data center infrastructure is designed considering the fact that they are going to provide certain services to certain applications. Services might be like storage services, web services, certain your business critical applications might be running XYZ. So data center infrastructure is what we refer to as the ACIE, application-centric infrastructure, and the controller that is responsible to manage that ACIE infrastructure is known as EPIC, Application Policy Infrastructure. Application Policy Infrastructure Controller for the data centers that are based on ACIE, application-centric infrastructure. Software-defined networking in the data center has been there like for very long time. Software-defined networking in the data center environment has been there for like very long time. when you start studying like software-defined networking, you will notice that the development of EPIC, application policy infrastructure controller, was done like way long before the SD-WAN and SD-Access came into the market. Cisco used to offer like other solutions as well, such as Open Daylight Controller. Open Daylight Controller, which was a Cisco's Open SDN controller, but it is now obsolete. So Cisco does not sell or support this controller anymore. It was based on like some open standard network foundation, open standard like automation foundation. It was an open standard controller that they created, but it is now obsolete. So like Cisco does not sell or support anything on this particular controller. So nowadays they have EPIC. Nowadays they have like EPIC for data center environment. They have SD-Access for the campus area network, and something called SD-WAN for the wide area. By the way, when for the ACI data center, when they created that EPIC, application policy infrastructure controller, and it started gaining a lot of popularity because of how easy it was to then configure the policies for endpoint EPGs, endpoint groups, and policies. It became like very easy to develop the policies for like the group of users, what users can access, what resources, what users cannot access certain resources and all. Creating all these policies became like very easy because of this application policy infrastructure controller that they started using. Slowly, like this EPIC gained like a lot of popularity in the data center environment. When this ACI data center, when this ACI EPIC was gaining like a lot of popularity in the data center environment, they thought of using the similar kind of thing in the enterprise network. They thought of using like, they thought of like developing a controller similar to the EPIC, but that can be used for the enterprise network, not for the data center infrastructure. And they did create it, and they called it EPIC EM. They called it EPIC EM, Application Policy Infrastructure Controller. EM stands for Enterprise Module. EPIC EM they created, Application Policy Infrastructure Controller. EM stands for Enterprise Module. EPIC EM was a different product, by the way. EPIC EM was a different product. EPIC was a different product. EPIC was for the data center environment, and EPIC EM was specifically designed for the enterprise network. Unfortunately, actually, EPIC EM could not gain that much popularity as EPIC. EPIC EM, like Application Policy Infrastructure Controller Enterprise Module for the enterprise network, EPIC EM could not gain like a lot of popularity, and slowly, like they disconnected that. They did not like, they stopped selling that EPIC EM controller. Like not a lot of people were convinced that we should use this kind of controller in the enterprise network. So it could not gain like that much popularity as the EPIC. So slowly it was like discontinued after a while. Meanwhile, other controllers were there as well. For the enterprise network, especially like when we have to manage the wireless infrastructure, wired infrastructure, they do have this at the time, like they have this another controller referred to as the prime infrastructure. I'm pretty sure that you might be familiar with it if your company is using it. But prime infrastructure, PI, prime infrastructure, or Cisco prime infrastructure, like it was created around in like this was launched. Prime infrastructure, Cisco prime infrastructure, it was launched around in 2012 something. In the beginning of the 2012, they launched it, I guess. Like do cross check from the documentation, although it's not needed. So Cisco prime infrastructure, PI, Cisco prime infrastructure, this one, Cisco prime infrastructure, basically they created. This is also a controller that we can use in our infrastructure, in our network. But as you can see, the prime infrastructure version 3.1, 3.10, the latest the version of the prime infrastructure controller, it is now end of sale, end of support, and its end of support will be in 2028. So if you are working on prime infrastructure version 3.10, it will go like end of support in 2028, end of sale 2023. It's already gone. So in the next 3 years, maximum to maximum, it will go end of support. They are very extensively, they are very heavily pushing a new controller in the production environment for enterprise network. You can refer to the documentation like on this, how to install this prime infrastructure, and what exactly is the prime infrastructure? Why do we use prime infrastructure? Prime infrastructure is a controller. It is something, a prime infrastructure provides a single integrated solution for comprehensive lifecycle management for wired or wireless campus area network branches. Okay, fine. So it's basically the similar kind of thing it is for the enterprise network. It is a centralized controller for the enterprise network to manage the LAN to manage the wired and wireless network from one centralized point. We can install it in some sort of server. We can install it in a server, and then this is basically an ISO image. We can download and install it in a server that is having like this much amount of CPU, this much amount of RAM and all. So this is currently what a lot of companies are using actually in their environment. This prime infrastructure still is in use by a lot of companies to manage their wired and wireless network from one centralized point. Epic EM could not gain a lot of popularity. Epic EM that we have, Epic EM could not gain a lot of popularity. That is correct. That is fine. But other controllers such as prime infrastructure that they created, it was able to gain like a lot of popularity, and the companies have started using this prime infrastructure very extensively in their production. You have to download the image, you have to install it, then you have to add or discover the devices and all, and then you can get from a centralized point, you can get the idea of the wired and wireless network. You can also see a lot of things such as network topology and the uses, CPU uses, RAM utilization on the devices and all. A lot of features are available in that Cisco Prime infrastructure. Then came in the market SD-WAN. So we had like Epic for the data center environment. Then they created Epic EM, but unfortunately that could not gain a lot of popularity. Then there came like Prime infrastructure. Prime infrastructure came like way before the proper like SD-WAN and all these things. So prime infrastructure, they created prime infrastructure for the campus wired and wireless network to manage all these points from all these wired and wireless infrastructure from a centralized point. And then suddenly SD-WAN started gaining a lot of popularity. SD-WAN basically software-defined approach to manage the WAN edge devices. So this is my enterprise network. And here are two routers that I have connected at the edge, which is connecting to the internet, maybe, or maybe connecting it to the private network, such as like MPLS. We have like n number of branches, and on all those branches, we have at least two WAN edge devices in each and every branch. So we have to manage all these WAN edge devices if you want to manage all these devices from centralized point. If you want to manage all these devices from the centralized point, then in that case, we can use the SD-WAN solution, software-defined wide area network, not only for the campus network, but in the data center as well. Assuming that this is your data center and internally you are using like that ACI Epic concept, but the data center also needs to be connected to the rest of the network, such as like internet or such as the branches, So in that case, we are going to also utilize some WAN edge devices to manage these WAN edge devices from one centralized point. We are going to use the SDN solution there as well. SD-WAN solution was also there in the market for a very long time. 2000. If you search on Google, you will find the videos regarding the SD-WAN in 2013, 14, 12, 13, 14 itself. There was a company called Viptela. Viptela, they created like a few routers that we can manage from one centralized point. Like Viptela, a company, they had a controller. They had some controllers and they had a few routers that we can manage from one centralized point. And slowly, this Viptela, this centralized approach to centralize the point from where we can manage, configure, control all the entire WAN network. It was also the SD-WAN was also gaining a lot of popularity. So in 2017, Cisco acquired Viptela. So it became like Cisco SD-WAN Viptela. So Cisco acquired Viptela SD-WAN. And in late 2019, 2020, when our curriculum, when the Cisco's official content for the exams and everything, it changed. They introduced the SD-WAN solution. They introduced a few certifications for the SD-WAN. They introduced a few content of the SD-Access in the network as well. But SD-Access was very limited. SD-WAN, they introduced the dedicated certification for the SD-WAN, and they introduced SD-WAN in the CCIE lab exam, in the CCNP and core, and they introduced it in a lot of places. And then in 2020, 21, 22, the SD-WAN gained like a lot of popularity. I'm not sure, maybe because of COVID, like, people are learning new technologies and all. So they, like, SD-WAN suddenly gained like a lot of popularity around in the same time period, 19, 20, 21, 22. So SD-WAN became very popular at that point. SD-WAN became like very popular at that point. Almost like a lot of companies have started using SD-WAN. They were migrating from the traditional WAN to the SD-WAN after knowing the advantages. Then different vendors came. Then different vendors basically joined the SD-WAN, and they provided the SD-WAN solution. There are like many vendors nowadays that provide the SD-WAN solution. Cisco is still the one, but there are other vendors. In fact, in the firewalls also nowadays, like we get the this SD-WAN solution, Palo Alto SD-WAN, and other vendors also have the SD-WAN solutions basically. And when SD-WAN started gaining a lot of popularity, what Cisco did, they revived basically this SD-Access. They revived this centralized controller that they created for the enterprise network. They more like restructured, they more like repurposed the Epic EM controller. In the Epic EM controller, in the same Epic EM that they had already created, in the same Epic EM controller, they added a few assurance, not a few, a lot. They added assurance feature. They added assurance features. Assurance more like means, day to operations, monitoring, troubleshooting and all. They added the assurance feature, and they launched a new controller to manage the campus local area network, campus LAN. And they called it like, they called that controller, which is responsible to manage the campus area network. They called it a DNA Center, Digital Network Architecture, Center, DNAC in short for the same. So DNAC is just repurposed, rebranded, revived Epic EM. It is still Epic EM. If I open the DNA Center, and a lot of places you will still see it says Epic EM, Epic EM, Epic EM. They basically, in the same Epic EM controller that they already had, they added assurance features. They added a lot of like tons of like artificial intelligence, machine learning capabilities. They added like monitoring, troubleshooting features and all. And they created a new controller called DNA Center.